Hello and welcome back to Chopstick Maths. In this video, we will be solving sum number 2 from exercise 4. Solve the differential equation, and the given differential equation is 3x square y raised to 4 plus 2xy dx plus 2x cube y cube minus x square dy is equal to 0. Let us call this as equation 1. Now, we'll have to first find out if this given differential equation is an exact differential equation or not. So let us compare this given differential equation with m dx plus n dy is equal to 0. Therefore, m is equal to 3x square y raised to 4 plus 2x and n is equal to 2x cube y cube minus x square. Now we'll have to partially differentiate m with respect to y, and then we'll have to partially differentiate n with respect to x. And if del m by del y is equal to del n by del x, then we can say that the given differential equation is an exact differential equation. So let us now proceed to differentiate m partially with respect to y. Therefore, del m by del y is equal to 3x square del by del y of y raised to 4. Now, whenever we are differentiating partially with respect to y, we have to treat x as a constant. Now, 3 is a constant and we are treating x square as a constant. Therefore, 3x square would come outside. So, this would be 3x square del by del y of y raised to 4. Now, similarly, 2 is a constant and we are treating x as a constant as we are differentiating partially with respect to y. Therefore, 2x would come outside. So, this would be plus 2x del by del y of y. Now, del by del y of y raised to 4 is 4y cube. Therefore, this would be 3x square into 4y cube plus del by del y of y is equal to 1. So, this would be 2x into 1. Therefore, del m by del y is equal to 12x square y cube plus 2x. Now, let us differentiate n partially with respect to x. Therefore, del n by del x is equal to 2y cube del by del x of x cube. Now, whenever we are differentiating partially with respect to x, we have to treat y as a constant. Now, 2 is a constant and we are treating y cube as a constant. So, 2y cube will be a constant and it will come outside. So, this would be 2y cube del by del x of x cube minus del by del x of x square. Now, del by del x of x cube is 3x square. Therefore, this would be 2y cube into 3x square, and del by del x of x square is 2x. So, this would be minus 2x. Hence, del n by del x will be equal to 6x square y cube minus 2x. Now, we can see that del m by del y is not equal to del n by del x. Therefore, this given differential equation is not an exact differential equation. Now, we'll have to find a suitable integrating factor such that when we multiply this given equation with that integrating factor, this given differential equation will reduce to an exact differential equation and we'll be able to easily find the solution for this given differential equation. Now, if del n by del x minus del m by del y upon m is a function of y only, say f of y, then the integrating factor is equal to e raised to integral f of y dy. Now, del m by del y is equal to 12x square y cube plus 2x and del n by del x is equal to 6x square y cube minus 2x. Therefore, del n by del x minus del m by del y upon m is equal to 6x square y cube minus 2x minus 12x square y cube plus 2x upon m is equal to 3x square y raised to 4 plus 2xy. Now, this would be equal to 6x square y cube minus 2x. Now, there is a negative sign outside the bracket. So, when we open the bracket, both the terms inside the bracket will change their sign. So, this would be equal to minus 12x square y cube minus 2x upon 3x square y raised to 4 plus 2xy. Now 6x square y cube minus 12x square y cube will give us minus 6x square y cube, and minus 2x and minus 2x would give us minus 4x upon 3x square y raised to 4 plus 2xy. Now in the numerator we can pull out minus 2x common. So this would be minus 2x into bracket 3xy cube plus 2, and in the denominator we can pull out xy common. So this would be equal to xy into bracket 3xy cube plus 2. Now the term 3xy cube plus 2 will cancel out each other in the numerator and the denominator, and here even x will cancel out each other in the numerator and the denominator, and we will be left with minus 2 by y, that is del n by del x minus del m by del y upon m is equal to minus 2 by y, which is a function of y only, and let us call it as f of y. Therefore the integrating factor is equal to e raised to integral f of y dy. So now let us substitute the value of f of y, which is equal to minus 2 by y. Therefore the integrating factor will be equal to e raised to integral minus 2 by y dy. Now minus 2 being a constant, we can pull it outside the integral sign. So the integrating factor would be equal to e raised to minus 2 integral 1 upon y dy. Now integral 1 upon y dy is equal to log y to the base e. Therefore the integrating factor would be e raised to minus 2 log y to the base e. Now we can simplify this integrating factor with the help of the property of log, which is m log a to the base e is equal to log a raised to m to the base e. Therefore we can write the integrating factor as e raised to log y raised to minus 2 to the base e. And we can further simplify this integrating factor by using another property of log, which says that e raised to log f of x to the base e is equal to f of x. So we can write e raised to log y raised to minus 2 to the base e is equal to y raised to minus 2, which is equal to 1 upon y square. Therefore the integrating factor would be equal to 1 upon y square. The integrating factor is 1 upon y square. Now we'll have to multiply equation 1 with the integrating factor 1 upon y square, and we'll get 1 upon y square into bracket 3x square y raised to 4 plus 2xy dx plus 1 upon y square into bracket 2 x cube y cube minus x square dy is equal to 0. So this would be 3x square y raised to 4 upon y square plus 2xy upon y square dx plus 2x cube y cube upon y square minus x square upon y square dy is equal to 0. Now here y square would cancel out each other in the numerator and denominator, and we'll get 3x square y square. Here y would cancel out each other in the numerator and denominator, and we'll get 2x upon y dx plus here y square would cancel out each other in the numerator and denominator, and we'll get 2x cube y. Now here there is no common factor in the numerator and denominator, so we'll have to write this term as it is. So this would be minus x square upon y square dy is equal to 0. And let us call this as equation number 4. Now equation 4 is obtained by multiplying equation 1 with the integrating factor. Therefore, equation 4 is now an exact differential equation. The solution to this exact differential equation is integral m dx keeping y as constant plus integral n dy and integrating only those terms in n which are free of x is equal to some constant c. Now m is equal to 3x square y square plus 2x upon y. Now we have to integrate m with respect to x and treat y as a constant. Therefore, y square will have to be treated as a constant and 3 is a constant. Therefore, 3y square is a constant and we'll have to write it outside the integral sign. So this would be 3y square integral x square dx plus. Now the second term is 2x upon y. The second term has a y in the denominator and we'll have to treat it as a constant. And the 2 in the numerator is a constant. Therefore, 2 by y will be a constant and we'll have to write it outside the integral sign. So this would be plus 2 by y integral x dx. Now, n is 2x cube y minus x square upon y and we'll have to integrate n with respect to y and integrate only those terms in n which are free of x. Now the first term has an x cube. Therefore, we'll have to neglect the first term as it has an x. The second term is minus x square upon y square. The second term has an x square in the numerator. Therefore, we'll have to neglect the second term also. So, we'll have to write it as plus integral 0 dy is equal to c. Now, integral x square dx can be integrated by this formula. Integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Therefore, integral of x square dx is x cube upon 3. So, this would be 3y square x cube upon 3 plus integral x dx can be integrated by using the same formula. So, integral x dx would be equal to x square by 2. So, this would be 2x square upon y into 2 is equal to c. Now, the 3 would cancel out each other in the numerator and the denominators. So, this would be x cube y square. Now, here the 2 will cancel out each other in the numerator and the denominator. So, this would be plus x square upon y is equal to c. So, this is x cube y square plus x square upon y is equal to c. Now, taking the LCM, this would be x cube y cube plus x square upon y is equal to c. And now we can write this as x cube y cube plus x square is equal to cy. And this is the solution to the given differential equation. Thank you very much for watching the video, and if you have liked the video, then please do consider subscribing to the channel. See you in the next video. Bye for now.